Hello and welcome to the first part in the series that we're putting together here at DKD Instruments on servicing the 8566B spectrum analyzer. We assume that you're here because you've got a problem with your spectrum analyzer and you want to try and figure out what it is. What you see in front of you is the RF section turned upside down so that you can see the insides of the instrument. And most likely this is the side you're going to have open to service it, as this is how it's made to be serviced, is from this side. There's a few things on the other side that you have to remove the cover for to get to service, but this is really where 99% of everything is going to be accessed through. So what's not shown is the display section here. This is the RF section, and the display section has its own problems, but the more difficult problems to find and to fix are in the RF section. So we're going to start here and discuss the RF section. So to get going, let's go over what's here in front of us in the RF section. Okay, so right here under this lid is the microprocessor board, the scan generator, and an interface board which connects to the front keyboard and all the digital control lines that go to the instrument. This is the power supply here, pretty evident. There's a big transformer, filter caps, there's the rectifier card right here. This section right here is where you find your power supply voltage regulators, these two cards here, and then most importantly the YIG oscillator control cards are here. There's a DAC, then there's essentially two cards associated with the driver to the YIG oscillator, and that's these two cards, A19 and A20. This assembly right here, which is rotated up and out for service, is the YIG oscillator assembly and phase detector. The oven oscillator OCXO is right here in the center of the instrument. That is 10 megahertz oven controlled, and if you don't allow the instrument to warm up and you turn it on, you'll get an oven cold indication. That's what is being done there. So when the instrument is plugged in, that heater is on all the time. This section right here and this section right here, these two sections are responsible for the frequency control of the YIG first LO. This is the M&N synthesizer, and it essentially provides 10 megahertz step sizes. There's three phase lock loops here, phase lock loop 1, 2, and 3, and they provide the fine frequency step size for the YIG oscillator. This section right here is the RF down converter, and the RF comes in here at the RF input jack, and it goes into this assembly here, which is contained here. And in this assembly you have your attenuator, your mixers, a YIG filter that has a mixer integrated into it. There's also a synthesizer here for an LO that is used in the first band. And this part of the instrument produces a 21.4 megahertz IF, and that is passed out of the instrument on the rear panel analog cable connector, and that goes to the display section. The display section has all of your resolution bandwidth filters, your video filters, and everything associated with the display itself. And so we're not going to be talking about those problems here. So in terms of what the overall concept of the instrument is it's a swept LO instrument, and that really kind of is in line with how the instrument came to be. It was the first instrument HP made from a line of instruments that were swept LO instruments, from the 8555, 8565 original, and some other earlier HP, the 8569. These were analog swept LO type of instruments. This instrument is really their first computerized version of that instrumentation, and they still retain the swept LO architecture. But what they did do is they added synthesis to it, and of course the digitization of the display, and that resulted in a whole really a whole another level of instrument. This instrument was really 20 years ahead of its time when it was introduced. So the architecture of the instrument is a swept LO, and that means here on this very front panel here you have an SMA connector, and the LO is there. And when you set up a start and stop frequency, this LO is sweeping, although offset by an IF, depending on which band you're in, it is sweeping that start-stop frequency. So all of the sweep is put onto the first LO. That's the key thing to remember. There is no other sweep. It's just the first LO is being swept. So if you have a problem, it's not going to be some other LOs being swept. It's the first LOs being swept. Although in the process of sweeping it, it does use other oscillators that are swept, but those are locked to the YIG, and in the end result is that you have a single oscillator that's being swept, the first LO. I don't want to be misinterpreted saying there's not other oscillators moving. There are other oscillators moving, but those movements are translated onto the first LO, and the first LO gets that movement of these other oscillators in the final lock. The other unique feature about the way this is a hybrid essentially of the old way of doing it and then the kind of the more modern way is that they wanted speed, and the way they did that, especially on wider spans, is that they didn't want to be phase locked all the time. That would take too much time to do, and so what they did is on the very first point of the sweep for spans above 5 megahertz, they would lock they would do a phase lock right there, and then they would do a sample hold. They would hold that, and then they would add on to that a ramp and sweep the YIG from that point forward. And so essentially for spans above 5 megahertz, you have a combination of phase lock and open loop YIG sweeping. You phase lock and then you sweep. You phase lock and you sweep. That's lock and roll, as they call it. Then that leads to some unique things about the instrument and some problems that are unique to just that. Sometimes you'll have a problem it's only on the open loop operation, and when you're closed loop you don't see the problem. So I'm trying to cover these things in kind of a list here, and pardon me while I go over my notes and see what I want to talk about here. So in addition to the first LO as the overall architecture being a lock and roll single LO swept system, it's a multi-band instrument. There are 5 bands in this instrument, and from the user it's kind of invisible. It's all coming in on this front jack here, but inside the instrument splits up the RF. And so there's the first band, which is from essentially DC or very near DC to 2.5 gigahertz. Then there's a band from 2 gigahertz to 5.8 gigahertz, a band from 5.8 to roughly 12, 12 to 18, and 18 to 22. Now, the key thing to remember is the instrument can't sweep through the band edge from the first band that ends at 2.5 and up to the other bands, because there's a mechanical relay. That relay's here behind the front panel, and if they swept that, it would be clicking all the time and it would wear it out. So it doesn't electronically allow you to sweep through there. It'll select which of the bands you're going to fall in. For instance, there's an overlap, and the bands above. There's a band at 2 to 5.8 gig. The instrument will automatically determine which band you're going to try and be in. But if you tried to sweep from 1 gigahertz to 3 gigahertz, it's not going to do it. It won't sweep that because it's going through the band transition. So you have to keep that in mind. Above the 2 gigahertz, it will automatically sweep through the other bands. Those bands exist electronically switched because they're really done inside the YIG-tuned mixer assembly. And so it's an electronic switching, if you will, and there's really no penalty for going from one band to the other. So it is a multi-band instrument. And that's really one of the key things in troubleshooting this instrument. I've kind of touched on these already, is there's differences in how the instrument is configured by span and band. So when you have a problem with the instrument and you're pretty sure it's here in the RF section, you want to try and figure out which band it's a problem in, or if it's a problem in all bands, and perhaps it's only a problem in certain spans. And so there you want to make sure that the problem manifests itself maybe only in spans underneath 5 megahertz or above 5, or perhaps below 100 kilohertz. There's another change in the synthesis below 100 kilohertz spans. So the instrument problems have to do, troubleshooting them have to do with span and band. And to get that resolved and figure that out is important to finding your problem. Okay, so the M and N synthesizer and the phase lock loop 1, 2, and 3, these are key to producing the phase lock of the instrument, not the sweep necessarily in terms of an analog sweep. That is handled by the scan generator here. These are what really provide the fine phase lock capability and spectral purity of the instrument when you get to the narrower spans, is M and N synthesis and phase lock 1, 2, and 3 over here. This M and N produces essentially a VHF type of signal that steps at 10 megahertz. And then the phase lock loop 1, 2, and 3 provides step sizes underneath the 10 megahertz. So if you have an M and N problem, it might only manifest itself on some multiple of 10 megahertz. Then you kind of know it's over there. If you have a problem underneath that, and that's more than likely, by the way, in terms of which is more likely, it would be in the phase lock loop 1, 2, and 3 and the finer step sizes. That's where more problems are likely to occur. The M and N synthesis is pretty robust, and this is usually not problematic. The phase lock loop 1, 2, and 3 are more problematic, and you often will see phase lock loop 2 unlock signal or display message, or phase lock loop 2, I believe. 3. So there's messages that will come onto the screen that'll tell you that, hey, this is unlocked. Well, that pretty much tells you got a problem. This doesn't tell you exactly why it's occurring. So with the combination of the M and the N, the phase lock loop 1, 2, and 3, the M and N, the synthesizer for the points where the YIG is synthesized have 1 hertz capability. So when you get down to the really fine step sizes, you'll find that all the synthesis is used. The reason I say that is because for spans between less than 5 megahertz and greater than 100 kilohertz, only phase lock loop 2 is used, and phase lock loop 1 and 3 are not. Get a little more into that in some of the later videos, how you can discern that. But that becomes helpful because you may only have a problem that is manifested in one area of span, and then you can kind of determine, it'll help you determine which phase lock loop perhaps it is in. Okay, so yeah, isolation of the problems is very important in terms of trying to figure out where you're going to go inside these chassis to figure out what you're going to do and where to go, and plan of attack. So you need to make sure you understand the problem of span, of what span it is and what band it's in. Can't stress that enough. Okay, not sure there's a lot more I'm going to talk about in this video in regards to the problems that are present in this instrument. But I would say that one of the more common problems that we've seen here, is a problem with the YIG, the first LO, and that results in a YIG unlock signal. Now, you got to make sure when you get a YIG unlock signal that it isn't something simple like the line is not getting to the CPU correctly, or a connection is broken or something. But you can get the unlock YIG signal from a variety of different places. But typically, if you just see the YIG unlock signal by itself, it's more than likely over here on this DAC, the drivers for the YIG, or perhaps some other interaction with these and the scan generator. There's a bad connection or something. If you get the YIG unlock signal and you get an M&N indication there's something wrong there, or a phase lock loop issue, that is a phase lock loop error or unlock, that will also make the YIG unlock signal appear. In other words, if I break open a phase lock loop, that will trigger not only that error on the screen, but it'll also trigger the YIG unlock, because the YIG can't lock without phase lock loop 1 or 2. So there is sort of a hierarchy of the error messages. In other words, the more of them that are on there, the worse the problem is, I guess, is basically, if you see multiple errors, it's going to be more problems to find. Other things to say right now, I think I'm pretty done. Let me look at my notes real quick. Let's see here. I think that's it for now. I think I'm ready to call this video done.